So the day two you started, I'm gonna go for it. This video is not prepared at all. This is real time. We're only 2 minutes into the day, so I haven't read anything about it. I don't know anything, so I assume the video is gonna be much longer than the first one. I'm gonna link the first one in the description, so if you wanna check it. Maybe you would like that more. It's much shorter, but this is gonna be me in my thought process through the exercise. Okay, I'm gonna start within day 2, 12:02 program alarm. On the way to your gravity assist around the moon, your ship computer beeps angrily about 12:02 program alarm. On the radio, Angles is already explaining how to handle this situation. Don't worry, that's perfectly normal. The ship computer bursts into flames. Okay, so that was not normal, I guess. You notify the elves that the computer's magic smoke seems to have escaped. Okay. The computer ran int code programs like the gravity assist program it was working on. Thoroughly, there are enough spare parts up there to build an int code computer. An int code program is a list of integers separated by commas like 10399. To run one, start by looking at the first integer called position 0. Here you will find the an opcode. Okay, so it's like a computer for real. Either 1, 2, or 99. The opcode indicates what to do. For example, 99 means that the program is finished and should immediately halt. Encountering an unknown opcode means something went wrong. Opcode 1 adds together numbers read from two positions and stores the result in a third position. Okay, so in this case is 100 and third position is I don't know. So the three integers immediately after the opcode tell you these three positions. Okay, so we're gonna index an array. That's bad for Rust. Okay. The first two indicate the position from which you should read the input values, and the third indicates the position at which the output should be stored. For example, in the encode computer counter 1, 10, 20, 30, it should read the values at position 10 and 20 at those values and then override the value at position 30 with their sum. Okay, it's cool, man. Opcode 2 works exactly like opcode 1, except it multiplies the two inputs. Okay, three integers after the whatever. As you are processing the opcode, well, next one is forward 4 position. Makes sense. But the following program is 1, 1, 2, 3, 2, 1, 2, 3. 99 is halt, right? Okay, 99 halts, but I don't get it. Okay, for the purpose of illustration, this is some programs split into multiple lines. The first 4 integers are whatever. Okay. I wanna skip that. So it's saying basically that the 10 contains 40 and the 9 contains 30, so you add and you put 70. No, it does. Whoa, I thought you. Oh, I don't get it, to be honest. Okay, I'm gonna read it better. Well, the first output is 1, yes. Two positions is 9 and 10, yes. And the position of the output is 3. The position 9 contains 33. 1, 2, 3, 4, 5, 6, 7, 8, 9. So if this starts in 0, very nice this. And the position 10 contains 40, yeah, makes sense. So it's referring to this. Add these numbers together to get 70. Okay, and then you store in. Override this, okay. Ah, okay, no. The opposite position 3 is at the position 3, okay, so that's why. It's 0, 1, 2, 3, makes sense. Okay. So step forward 4 positions to reach the next opcode is 42. This opcode works just like the previous, but multiple instead of adding. Okay. 3 is 70, and 11, which is 50, right? And you get into 0. 4 more bytes, you get 9, halting the program. Okay, these are good test cases. I see that already. And those are smaller than the other ones, so they are better. Okay, result of gravity. Okay, so let's turn this into test cases. So I'm gonna cargo new day 2, right? Day 2. I'm gonna, since I know I'm gonna do test for sure, right? I'm gonna use cargo watch. I'm gonna execute the test, and also I'm gonna execute FMT, the formatting, all the time, every time I change a file. Okay, so I'm gonna open folder, up, go H2, select folder, name, close this tab, and then here we have the test module. So again, I'm gonna explain this fast. The thing is, basically here we have starting a module. This doesn't need to have this, right? But when we put this, it means that this only compiles when we are testing, when we are running cargo test. If we are doing cargo run, this doesn't compile. So we don't include all the code that is here inside the binary. So we can have different dependencies, and we can avoid bloating the binary. Yeah. We also avoid stressing the compiler. That doesn't need to go through here. So I'm gonna do the dump test function just to be sure that everything is working. And you might wonder, your IDE is saying already run test, right? Why don't you use the IDE for that? I could. If I do this, it's running the test too, but to be honest, for me it's more comfortable to check the console like this. I have this like in Quake, one button, and even I could, for me it could be even better if I want to have it in the side. So, well, wrong. I don't know why it sometimes doesn't work. Sometimes it works. Okay. Windows behave. Yeah. That's what I wanted to do. I don't know why it doesn't. Okay, it drags. We're good. Okay. So we are running one test. Let's actually do the thing. So again, we have here we have the input, and here we have the expected result. I don't know why we have this, the parentheses. Because it's telling you what it does. Okay, so it's not needed. So I'm gonna call it by now computer, and I'm gonna, since this is an array, I'm not sure the type, to be honest, so I'm gonna just type the numbers, but this might change later. Computer. Okay, in any case it will be a slice, and it will return a back probably. I don't know if back implements equal. I don't think so. So maybe I'm gonna test with string better. 2 0 0 0 9 9. I can get string from this by now. So computer, I'm gonna take input, which is gonna be a slice of integer, and by now I'm gonna return static with this actually thing. You will see that it's gonna be okay by now. Well, of course, it's not in the scope. Super. So because I don't want to import all the functions all the time, I'm gonna just do asterisk, and this is gonna import everything in the parent mode, which is the super mode. Okay, it's working, but of course this is totally fake. So I'm not gonna be able to return static str for sure. I'm gonna have to return in any case a string. So I'm gonna do this already. I don't know if this is gonna compile like this. Yeah, because you can compare string and str. Okay, so let's be a bit more realistic. I'm gonna put maybe here a dump function, which is gonna be my helper for testing. It's gonna take a back, and it's gonna return the same. So it will do here. It's gonna be here. It's gonna be this, and here we will have a proper back. Okay, this still works, obviously. So let's do things a bit more proper. But this should work, no? Not found. But concat was there, no? Is this a meter? It's on a slice. Okay, so if I do this, it should work, no? Or if I do as a slice. Easy. Let's see what they told us. No, it's nightly. It's not stable. Okay. Then let's see what we can do. Oh, this is a mess. Let's see this. In PHP they call it inflow. In JavaScript I don't know, a join. Okay, maybe it's join. Okay, it looks like yes, it's called join. So but it doesn't exist for slice, maybe for back. Doesn't exist for back. Okay, I need to I'm not sure if this is stable or not. I think it's not, no? It says it's unstable. I didn't read the proper the Stack Overflow message for real. Okay, let's see what they got here. Ooh, yeah, they got this is stable. So they got join, but this doesn't work for me. Stable. Nightly. It doesn't say anything. Well, because maybe they need to be a vector of string. Yeah, that would make sense. So if I map to what's the map? To string to string. As always, this is like that. Okay, works. Well, took a long time. Anyways, it's working. So the dump function works, and we only need to take to care to return a vector, which is it looks more correct. Okay, so this test case is working because I hard coded. Let's go for the next one. I'm gonna copy paste this first. I'm gonna copy this. Here. Of course, it's gonna fail because the second case is not working. Okay, let's start doing things then. Okay, yeah, everything needs to start with an index. And with a result. The result is gonna be like that. Like that. Okay, so I'm gonna match on result index. Let's see if they allow me to do that. Looks like it's not running anymore. Okay. So this compiles. Just gonna do the first case. In the first case, we are gonna take, let's say the first is index plus e. I'm not sure if this is gonna work. Oh, plus one. Sorry. Okay, we got some error. Okay, this is saying that we don't handle all the cases. So, but this works. Okay. So then let's second index plus 2, and then third index plus 3. So basically we will have result index, sorry, result first plus result, result second into result third. I don't think this is gonna work right away because we need queue size. This is something a bit inconvenient, but expected. We need to explicitly casting. Okay, this works for the first case. Let's go for the second. So if I remember correctly, this was multiplying, no? Yeah, working. Okay, let's go for the next case. I'm gonna rename this function. Should be more like print. Or stringify. I like stringify. And then the solution should be, the expected value should be this. Okay. Well, this already works, this one. Didn't expect that. Okay. Notice that I'm not checking the length of the array, which is quite dangerous. But I don't know. So far we don't need it, so let's hope this test case cover all the cases, but I don't think so. It's funny that I'm not reading the 99, but I should. Okay, this one is not working. And it's not working because I'm not reading the 99, as I was saying. So what we will do is index was plus form, then 99, which is gonna break. Just gonna put this in a loop. Let's see format in action. Okay, it's working. So it looks like everything is working. So easy, right? This computer thing, I'm gonna call it like they call it in the exercise. Encode program, so we call it encode computer. So I'm gonna let it like that. So once we got this functionality, I'm gonna go to the input. My god, it's horrible. I'm gonna just put it here. Of course, it's gonna be an array of e64. I don't know. Let's see what the compiler has to say is 149 elements. Okay. This could be a mech, but that way I can make it const, which is a bit nicer to work with. It's more flexible, or is less flexible, but it's all in memory. I don't need to allocate memory for that. Okay, so if I do them computer of password input, which I should slice. I want to know what is the result, but the result it will be the last value, what value is left at the position 0. Okay. Then it will be more like that. So the first part is all 0. And then for the program. So according to this, the result is 337061. It's crazy. Let's see if I got it right. Oop, it's not. I don't want to ask hints, I just want to make it work. Okay. I think it's because 99 is breaking. I shouldn't break, no? Because how many 99 are here? Okay. It shouldn't break, it should use. I'm not sure. Okay. Maybe it's because I should do index plus 1. I'm gonna read the documentation before. Where is the 99 opcode? Well, I don't see it. Okay, 99 means the program is finished and should immediately halt. When containing an unknown opcode means something went wrong. I'm gonna, in order to reflect this, I'm gonna put a panic. So, let's see if I at least got a panic. No, I don't get a panic. Get the same result. Ooh, that's something I don't like. Test cases are fine, but the value is not. Let's see if I got the test cases correctly. 11499, 11499, 56099. Strange. What value is left at position 0? Okay, let's see. With this, once you have a working computer, the first step is to restore the Gravity Asset program to the 1202 program stated this before. Okay. Replace, oh my god. Replace the position 1 with the value 2 and replace the position 2 with the value 2. So, I don't know if they asked me to do this before or after. I'm gonna use go for it before running the program. Okay. So you please program back. Program position 1 program position 2 left. Current port was mutable because I didn't say smoothable, of course. To put it here. We have a different number now. Let's see. That's the right answer. Okay. That happens because I didn't read the whole thing. Okay, part 2. Good, the computer seems to be working correctly. Keep it nearby during this mission. You'll probably use it again. Real Intel computers support many more features than your new one, but we'll let you know what they are as you need them. However, your current priority should be to complete your gravity assist around the moon. For this mission to succeed, we should settle on some terminology for the parts you already built. Encode programs are giving us a list of integers. These values are used as the initial state for the computer's memory. When you run an encode program, make sure to start by initializing memory to the program's values. Position in memory is called an address. For example, the first value in memory is at address 0. Codes like 1, 2, 99 are the beginning of an instruction. Okay, this is first year's computer science. It's kind of boring. For example, in instruction 1, 2, 3, 4, 5, you told me this already. Come on. The address of the current instruction is called instruction pointer. On starts at 0, the instruction finishes, instruction pointer increases by the number of values in the instruction. This is always 4, okay. Okay, the halt will increase the instruction pointer by 1, but it halts. Okay. It's already auto, the way you're ready to proceed to complete the gravity assist, you need to determine what pair of inputs produce the output. Oh. What pair of inputs? Noun, verb. I don't, but this is estimated what a pair of inputs produce output. Once the program has halted, this output is available at address 0. Also, just like before, each time you try to a pair of inputs, make sure you first reset the computer's memory to the values in the program. So we need to find noun and verb that cause the program to produce the output whatever. What is 100 times noun plus verb? Okay, I'm doing some water. Noun is 12 and verb is 2. The answer would be yeah. So okay. I'm not sure what it means by input should still be provided by the program replacing values. Okay. So before the noun was 12, no? Yeah, this is the noun. Okay, understand. the verb. Okay. So basically what I need to do is find noun and verb, so the result is that. And I think I need to multiply them. So we'll be between 0 and 99 inclusive. So I need to do double for each, that's it. But I don't get, this is the formula we need to use in here. So, I don't know. Okay, so I think this is like that. So I need to check if the output is this. I'm gonna copy paste now better. So like that, and then I'm gonna do the check here. Result is this number. I don't know if I should do it like that. Yeah. I'm gonna put this in this one, which I think is not possible. To make sure this. Okay, 64. Oh, there is no. It's like this. Okay, so output will be 100. Then I just like to put things outside of nested shit. I'm gonna break here. I don't know exactly how to do this. Outer. No, I think that this works. I need to put this. Break on its own. I don't get it. Why? Like this, no? Why not? Yeah, should work. Well, Of course, I'm printing the same thing. I'm gonna put output. So output is this according to tada. Yeah, done. So that was it. I'm gonna maybe, I don't know, I don't think I need to refactor really. So things are quite broken here. If you don't check the array length and stuff, it could really make a mess, but it works. So just don't spend more time on that. So I'm gonna commit it and that's it. So with this, bye bye everybody. You can check the code in the repo. I link in the description. And I wish you luck with the exercise. Bye bye.